Unit 7, Lesson 2. So solving second-degree trig equations. So here's the thing that's crazy is we're going to be factoring trig equations. Okay, we're going to be breaking them down using our factoring skills to write them simplified so we can solve them. Okay, so factoring trig equations or expressions, just as a polynomial, use your same skills you used before. Some people don't like the trigs. It really messes them up. If you want to sub in a variable like an a or something there so it looks better to you, you can do that. I don't need to do that. You can if you'd like. So what we're saying is you just simply still ask yourself, what do they have in common? Okay, what do they have in common? So like this one, if I'm factoring that, they have a 4. So then it's 2 tan a plus 1. That's it factored. Okay. Okay. Second one, they have a sine x in common. Who thinks they can factor c? What type of factoring is c? Yeah. Difference of squares. Yeah, so it's a difference of squares. 4 is a perfect square, sine squared squared, and 1's a perfect square. So it's like, think about it this way. If it was like this. Right, 2x plus 1, 2x minus 1. So this is 2 sine 1 plus 1. 2 sine minus 1. Yes, sine x, of course, thank you. Sine x, if I can slide that in there. Probably can't put it there. Sine x minus 1. Okay. Third one, got that trinomial look, so you're doing factors. So what factors of 28 are 3 apart? Factors of 28 that are 3 apart. 7, 4. And then it's a negative 7. So then you go cosecant x minus 7, cosecant x plus 4. Then the last type, the decomposition, which you probably don't like that much. 2 times negative 4, negative 8. Factors of negative 8 that get you a positive 7 is 8 and negative 1. We break the middle up into those factors. Gotta bend down here a little bit. So then we're going to group in GCF. The first group has a 2 cosine in common. We get cosine x plus 4. The second group has a negative 1 in common. Cos x plus 4. And now we're good. We got the match, the factor that matched. So it's 2 cosine x minus 1 cos x plus 4. All right. Questions on that? So it's stuff we know with some ugly stuff, I'd say. You're doing stuff that you know with some uglier trig like letters, but still the process is the same. Okay, and then we'll kind of talk about what we're going to do with that. So before we actually do it algebraically, let's go ahead and do it graphically. So we'll do the intersect method again. So we're going to solve this equation. We're going to put this into y1, this into y2, and we're going to go ahead and solve. Okay, and then we're going to give the general solution for this one because we're going to say it doesn't have, they're going to say if it didn't have a restriction, what would you do? So y1, y2, let's do it here. Okay, so go y equals, we're putting in 2 sine squared x. So how you put the 2 sine squared x in, you go 2 bracket sine x, and then you square that like this. Okay, actually, sorry, I'm going to go ahead and I like to put one more bracket in, like that. There you go. That's 2 sine squared x. Okay, and then you're going to put 1 minus sine x in the other one. What's that? No, you don't have to. I think the same one works okay. Yeah. So that same one you have been doing, it works fine. And so when you're looking at this here, you'll see that you have this spot, and this spot are solutions. Okay? So we'll just use intersect to find one of them. That's going to be repetitive. You guys know how to use intersect. Okay, but we'll do the same thing that we talked about earlier in terms of finding the exact value. So let's do second trace. Let's just see which one it finds for me. I'll let it pick. So it's going to probably find this one. Enter, enter, enter. So it gave me this one, 2.6179939. So we're going to go second quit, x, enter, divide by pi, fraction, 5 pi over 6. So that middle one, the middle one's 5 pi over 6. Okay, if you did the first one, you got a different number, but I'm not going to do all three. Okay? The middle one. The middle. There's 3, so the middle. Right here? Yeah. That one.
I saw a different window.
Oh, okay. Sorry. What's that? No, I'm just going to do one. Is that okay? Okay. So this one, we do have 3 solutions. So going back to this, we have, so we got the middle one, as I said. So we got 5 pi over 6. And see, this is what we're talking about, Hannah. See how it says here? Write solutions exact multiples of pi. My calculator didn't give me that. So I had to do that process to get those exact values so that I was not in decimal form. Sure. Yeah, let me write these down. I'll go down and do it one more time. Okay, so 5 pi over 6, and then the, oh, this is the algebraic approach one. I'm missing a page here. So then, yeah, and then pi over 6 is the first one, and then 3 pi over 2 is the third one. And then to write these in general form, you would write pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, and 3 pi over 2 plus 2 pi n, n-e-i. Okay. All right, and then we'll go ahead and show that process one more time. Okay, so the process to get exact. So second trace, we'll do the intersect just one more time. Enter, enter, enter. Okay, so there's my value, 2.61. Second quit, hit the X key, and hit enter in your calculator. It gets that 2.61 for you. Divide by pi. Enter. This is the value in radians with pi taken out. So it's the fraction that pi is being multiplied to. Math, fraction, enter. 5 over 6. So that means that location is 5 pi over 6. Okay? All right. So now we're doing the algebraic approach. So using the algebraic approach to determine the roots of this equation. So how would you guys do this algebraically? What's that? Factor it. Yeah, well, what do we do before we factor, though? Move it all to one side. Right, so you're going to take the same principles you've been using for a lot of years, I could say. Okay, we're going to get 0 on one side. So we're going to have 2 sine squared x plus sine x, write it in the correct order, minus 1. Okay, and so this is a decomp problem. We have to decomp this one because 2 in front. Okay, unfortunately. So we have to go 2 times that, so it's negative 2. Factors negative 2 that get you 1 is 2 and negative 1. So it's going to be 2 sine squared x plus 2 sine x minus sine x minus 1. Like that. And then we're just doing the part where we pull common out. 2 sine x comes out. Sine x plus 1. Pull the negative 1 out. Sine x plus 1. Okay. And so we get 2 sine x minus 1. Okay. So there's where we're at factored. And I'm going to ask you, what did you guys usually do when you get down to everything factored? What do you do to find solutions? Yeah, you used to do what makes the x 0, right? Thinking the same line, but we don't have an x now, we have a sign. So essentially you're saying, how do I make this case 0? So the answer here is when is sine -1? Because the -1 plus 1 is 0, right? So you're essentially setting both pieces equal to 0 and solving. Okay? So what I'm trying to get at is, okay, you guys are used to this, right? If I had this factored, you tell me your zeros are -1/2 and 3. Unfortunately, we have sine now. So we need to figure out, it's not that bad, because these are actually, you should be happy about these ones, because this is saying, when is sine? Add the 1, divide the 2. When is sine 1/2? When is sine -1? Those values we're familiar with. Correct, -1, 270. It wants it in radians though, so it wants 3 pi over 2 for this one. Okay, so if you missed that, she's right. We want when sine is negative, sine x is -1. If you're not sure, you don't like seeing that, you simply can do this. Solve. That's what it's doing, right? When sine x is -1. Mm-hmm. Mm-hmm. Nope, it's positive because we're going to add, because when we solve, we get positive, so that's what we want. Because no way you can think about it is if I put 1/2 here, 1/2 times 2 is 1, 1 minus 1 is 0. So we want a positive 1/2. Okay? Yep, pi over 6, but also 5 pi over 6. The other 1/2. Okay, so I'll show this too here. You guys are asking great questions. Good, you guys are getting it. I see the... Okay, so add the 1, divide the 2 is what's going to happen. If you're not seeing the mental math part, that's okay. Divide 2. So you're simply solving when sine of x is 1/2. And then as Natalie already said, sine's 1/2 here and here, which is pi over 6 and 5 pi over 6. That's your answers. Both. Pi over 6 and 5 pi over 6 is 1/2 for sine. Both those values, right, Hannah? Which other one? -1? Right, which we did, 3 pi over 2. So we have 3 solutions here, which we had 3 solutions, right? This is the same one we just did, isn't it? Okay, so then state the general solution. So this is just a simple thing again, guys. You got pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n. We already wrote this in the previous page, so you don't have to if you don't want to. And NEI one last time. We'll do 2 more questions, or no, I guess 2 example sets with 2 each. So we're doing a couple more examples here. All right, you guys already have this down here, so we can go, like, you don't have to write the general solution thing one more time if you don't want to. All right, so let's look at this here. Use an algebraic procedure to determine the roots of the equation, give the domain on the given domain. Okay, so we're staying between 0 and 2 pi. All right, good. Solving for a is just a variable, doesn't matter. Ax just happens to be a. They gave us the one we already factored earlier, so we know this factors to 2 sine a plus 1, 2 sine a minus 1. Right, so we're looking for when sine a is -1/2 and sine a is +1/2. That's cool because we essentially just want what? We essentially want all 4 spots for sine of 1/2, positive and negative. So we want every location that it's 1/2. Because it's 1/2, like she said, we just did 1/2. Sine's 1/2 here and here, but we also want these 2 as well. So we want all 4 reference angle spots. It's in radians, so we want the pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are your positives. your 7 pi over 6, and your 11 pi over 6 are your 2 negative 1/2. Does that make sense? Okay, are you guys okay with the general solution? Do I need to keep writing that? Okay, so just be all 4 of those plus 2 pi. Okay, and actually, technically with this one, yeah, I guess with this one you could cheat a little bit. You could go this one plus pi, this one plus pi, and be done. Right? Lands on there. Lands on there. Could do that. Okay, this one here, tan squared x, tan x. So simply pull out a tan x. So we have tan x plus 1. Okay, so what do we want the first piece to be? 0, good. Okay, so we want tan x to be 0, and we want tan x to be negative 1. Okay, well, where do we like spots for tangent? Where are they nice? They're nice there too, but in terms of if you actually do the ratio, the 45s, right? Tan at 45 is the 1 spots, right? So the tan negative 1 is your negative locations for 45 degrees of comparing x and y. Or you can use CAS rule. So tangent is we want it negative, right? Tangent's negative here and here. Say that again. Just 3 pi over 4. We don't say it negative, just 3 pi over 4, but you're right. Yep, 3 pi over 4 is 1. That's this one. Thanks, Jake. Jake got that one. What's this one? 7 pi over 4. Good. You guys are making me proud. A little tear in the eye. Okay, where is tan x 0? So here's the hint. We can't divide by what? So we're looking for when y is 0. Right, so 0, pi, 2 pi. All 3 of those, right? Because why do I put all 3 of them? Look at your domain. It says include 0 and include 2 pi. Okay, so we do have 5 solutions there. Okay, yep. We got all 5. And then again, general, just add 2 pi to all of them if you'd like. You could also simplify it for that one on the left. It could just be pi in, so every pi is a solution. And then it could be 3 pi over 4 plus pi as well, if you want to simplify it. But. Okay, here we are, last couple. All right, so this one says, I guess we want to see the directions here. Determine the zeros of the following functions on the specified domain. Okay, so we're looking at the zeros of the following. Okay, so cosecant squared x minus 3. So they're nicely giving us the ones we've already factored, yeah? We factored this one earlier. So it's going to be cosecant x minus 7, cosecant x plus 4, right? So now these are, hopefully you understand, these are spots that aren't on the unit circle. Okay, 7s, those don't look familiar. So just be okay with that. How would you set this up to solve, though? Because they're not in the unit circle, we have to use inverse, right? So if we're going to use inverse, we can't have cosecant anymore. We want to switch it to what? Sine. So if cosecant x, this one's 0 when cosecant x is 7, right? So then it's going to be sine x 1/7. This one's cosecant x negative 4, so sine x negative 1/4. Okay, now here's the thing that's a little tricky. We kind of can like cancel one off. Can anybody really impress me and tell me why? Why can we cancel one off? Yes, Bree. Go ahead. Oh. Correct. Domain says 0 to 180, so I'm only on the top piece. I have no negative signs. So that won't happen. Solution. Okay, sine x of 1/7, so we simply go sine inverse of 1/7. When you do sine inverse of 1/7, it gives me degrees, so we can keep your calculator in degree mode. You get 8 degrees. Okay, so that's your reference angle. It's also one of your answers because your answer's in quadrant 1 and quadrant 2. So we got 8 degrees here, and we're going to get 172 there. All right. 180 minus 8. Okay. All right, last one. Doing a good job, doing a good job. Way to truck through. Okay, got to do decomp, and we're going a little bit interesting here. We're going from pi to negative pi, so, or negative pi to pi. It is, but it is, but it isn't because we're going to express our answers. Okay, it is and it isn't. So like, if I go negative pi is here, and positive pi is here, so you're right, we're really just in one revolution, but we can't use like 3 pi over 2 is not in there. So when if we're down here, we have to switch to the negative values. Okay, so listen one more time. This is clearly -1 to 1. Let's just talk about whole numbers. 3 over 2, 1.5 is not in there. So if we get an answer right here, we just answer that normally. That's cool. If we get an answer right here, you need to do the negative value. It is, but that's I think that's a diploma thing. It's not hard. Sure, it's stupid, but it's not hard. Okay, so now we got to do our decomp factoring. They're making us work here. So -6 factors -6 get you 5. That's going to be 6 and -1. So we got 2 cos squared theta plus 6, sure, plus 6 cos theta minus 1 cos theta minus 3 group. We take a 2 cos theta out. So we got 2 cos theta came out. We have a cos theta in and a 3 in. Take a -1 out. We got a cos theta and a 3. Sorry, I'm writing crooked there. Okay, so it turns out to be 2 cos theta minus 1 and cos theta plus 3. So we want cosine. We want cosine at 1/2. And we want cosine at -3. Okay. Okay. So cosine of 1/2 is one we can do. Cosine -3 we can't do. Okay, so because it's going to be outside the domain, but we can try it if you want. The reason that -3 is outside the domain is because it's too high, and so then therefore the arc length's not going to work. Yeah, we just can cross that one off because it's going to be it's outside the parameter. If you guys real quick go ahead, what is inverse cos of -3? Does it say anything or does it say error? Okay, so that's also why. Okay, so we got no solution here. Okay, the 1/2 cosine of 1/2, so we're looking for the x to be small. So x is small at these locations. Okay, and so we want just positive 1/2. So we want this one, and then we want this one. We already did that bottom one for the negative, so that shouldn't be too bad. But the positive answer for this guy is pi over 3. And then what's the other one? Just back that far, right? Negative pi over 3. So it's pi over 3 this way, negative pi over 3 that way. That's how you can write it so it's within the parameters. Like when Bree is talking about it with 5 pi over 3, that is 5 pi over 3, it's correct, but we have to write it negative pi over 3 because of the domain. Okay, that's it.